Today's lesson is 1.6, representing functions as rules and tables. Our goal is to represent functions as rules and tables. This is something that's going to come in very useful in Chapter 4 when we start to graph equations. So you will see this information again in a few chapters. We have several vocabulary words for this section. The first is function. A function is a rule that establishes a relationship between two quantities, called the input and the output. For each input, there's exactly one output, and we are going to be defining a function and deciding whether something is a function or not. Next we have domain. The domain is the collection of all input values, so we need to keep that in mind, that domain is input. The range is the collection of all output values, so range is output. Then we have independent and dependent variables. Independent variables are the input variables, so independent is going to go with domain and input. And dependent variables are the output variable, so dependent is going to go with range and output. In example 1, we're going to identify what the domain and range of a function are. The input-output table shows temperature over various increments of time. Identify the domain and range of the function. Well, our input is our domain. So our domain is 0, 2, 4, and 6. Our output is our range. So it's 24, 27, 30, and 33. In our first checkpoint, we're going to do exactly that. We're going to identify the domain and range. So pause while you work on this. The domain, again, refers to the input. So 4, 7, 11, and 13. And the output is the range. 10, 20, 35, and 45. In example 2, we're going to tell whether the pairing is a function and explain our reasoning. And there's a box off to the left here. It's pointing to this mapping diagram right here. They're used to represent functions. It says take note of the pairings to make your decisions. So 4 is paired with 1, 8 with 2, and 2 with 3. Well, A is a function. The reason that it's a function is that each input is paired with exactly one output. So each input has exactly one output. When we put in a 4, we got out a 1. An 8, we got a 2, and a 2, we got a 3. In B, this one is not a function. The reason is that you cannot input a 2 and have an output of a 2, and then input another 2 and get an output of a 4. Every time you plug in an input, you should get the same output. So this is not a function. Two is paired with 2 and 4. Okay. So again, pause while you work on your checkpoint. For number 2, 2 is not a function because you have a 5 paired with a 3 and a 5 paired with a 4. You cannot do that. Not a function. Number 3 is a function. 0 is paired with 3, 4 with 5, 12 with 9, and 20 with 13. One hint is that if none of the input values are repeated, you are going to have a function. And number 2, the 5s repeated, and they had different outputs, so it was not a function. Our next box is talking about what functions are. We're relating verbal rules to equations to tables. Off to the side it says a function may be represented using a rule that relates one variable to another. So here is our rule. The output is 2 less than the input. Okay? Our output is going to refer to the y, and the input is going to refer to the x. So the output is y equals 2 less than the input. That's x minus 2. So when we're making our table, we're going to take our input values and substitute them in for the x. Okay, so we're going to have 2 minus 2, y equals 2 minus 2. 2 minus 2 is 0, so our output is 0. Then we'll do 4 minus 2, which will give us 2. 6 minus 2 will give us 4. 8 minus 2 is 6. And 10 minus 2 is 8. And that is how we fill in an input-output table. In example 3, we're going to make a table for a function. They tell us that the domain is 0, 1, 2, and 3. When they tell us the domain, that is what we are going to put in place of the x. So in our input-output table, we're going to put in a 0, 1, a 2, and a 3. And to get our y, we're going to substitute it into the equation that they gave us, y equals 3x. So 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6, and 3 times 3 is 9. Then it told us to identify the range of the function. Well, the range refers to the y values. So that's 0, 3, 6, and 9. In example 4, we're going to actually take an input-output table and write a function from it. Okay. So our inputs are 3, 5, 7, 9, and 11. Our outputs are 6, 10, 14, 18, and 22. X is going to stand for our input, and Y will stand for our output. If you notice, each output is twice the corresponding input. 3 times 2 is 6, 5 times 2 is 10, 7 times 2 is 14, 9 times 2 18, and 11 times 2 22. So a rule for the function would be y equals 2x. You're just looking for a pattern within the inputs and outputs. And for our last checkpoint, you might try to stop this and attempt the problem on your own. When I look at my inputs to my outputs, and the yard is the input, and the total cost is the output, we need to figure out what is going on here. One easy way to look at this is to find the 1 in the problem, if there is one, and to see how it changed, how we could get from 1 to a 1.5. Well, one thing that I could possibly have done is added a 0.5. Okay? But if I go to my next column and 2 plus 0.5 is not 3, that won't be it. It is getting larger, so we want to try something that also will make it larger, which would be multiplication. The reason we look at 1 is because whatever you multiply 1 by would give you the same output. So 1 times 1.5 is 1.5. 2 times 1.5 is 3. 3 times 1.5 is 4.5. And 4 times 1.5 is 6. So that's what we're looking at, is multiplying by 1.5. So the equation that we're going to write, or the function rule, is y equals 1.5x. Then it says identify the domain and range. That information is already given to us. We just have to list it out. The domain refers to our x's, or our inputs, so 1, 2, 3, and 4. And the range refers to our outputs, which is 1.5, 3, 4.5, and 6. And that concludes lesson 1.6.